Warm greetings. Welcome to Wednesdays for Water. We are a citizens collective aiming to walk and talk water. We try to meet every week and connect people with various water worries and wisdoms. And in the process, we wish to curate future water warriors. The way we talk about trivial things for hours, water too needs walking and talking to address the rising water distresses. The way Wednesdays for Water is conceptualized as a prime time show, it wishes to make water everybody's business. The idea of the series was conceptualized in August 2020, and by the end of the year, the team and the structure was pretty much in shape. We started in April 2021 with Dr. Rajendra Singh's inaugural speech. We wish to bring science and society together, and therefore we try to bring in every session either a policymaker or practitioner and a researcher or academician. We also think that future generation is crucial and therefore they have presence in each session. We are going stronger with every week now with session on either quiz, couple of weeks of hard talks, and a week of soft session of art and music. There is a simple structure for each session of quiz, hard session, and soft session, which are moderated by the core team member. Here is a glimpse of what we call as hard sessions and soft sessions.
So good evening, everyone. I'm Suparna Katyiani from TISS Hyderabad, and a warm welcome from our Wednesdays for Water session today. A very happy new year. I think this is the second event of this year, and the theme of today's session is emerging pollutants and contaminants in water. So just a very brief about this theme. So United Nations Environment Program, in short, UNEP, describes emerging pollutants as chemicals and compounds that have recently been identified as dangerous to the environment and consequently to health of human beings. These pollutants include a wide variety of contaminants called as antibiotics, drugs, steroids, endocrine disruptors, hormones, industrial additives, chemicals, and also microbeads and microplastics. They have been labeled as emerging because of the rising level of concern linked to them, and many of these emerging pollutants have not been regulated under national or international legislations. Therefore, they are posing a great risk to our well-being. So to discuss various aspects of these emerging pollutants in water, we have two very important speakers with us today, Dr. Girija K Bharat and Dr. Paromita Chakraborty. Thank you, ma'am, for joining us today for this session. I would just like to take a minute to introduce our speakers to our participants. So Dr. Girija is the founder director of Mu Gamma Consultants Pvt, situated in Gurugram. She is an international expert with 3 decades of research and capacity building experience on issues of water quality. She is the recipient of several awards, including the Global Environment Award and Aqua Excellence Award in 2020. She has about 90 national and international publications, which include the Global Sustainable Development Report of 2015 and 2016. She is also currently drafting the National Policy of India on safe reuse of wastewater, which is very relevant to our discussion today. And our second speaker is Dr. Paromita, who is the Associate Professor at the Department of Chemical Engineering in SRM Institute of Science and Technology in Kattankulathur, India. She leads the Environmental Science and Technology Research Group there, which is engaged in intensive research on emerging organic contaminants. With the support of national and international funding agencies, she has also published more than 90 scientific articles in peer-reviewed international journals and as book chapters. She also serves as an editorial board member in journals like Science of the Total Environment. She was awarded with Hiyoshi Environment Award in 2020 and prestigious Water Advanced Research and Innovation, in short, WARI Fellowship of 2016. We also have Ms. Aradhna joining us today as the discussant. She is currently pursuing MA in Natural Resources and Governance from TISS Hyderabad. So we just have one or two housekeeping announcements for the people who are joining us today. We would like to record this session. It's already being recorded. So please, we would like to thank you for your permission to record. And we would also like to request the participants to keep themselves on mute so that we can hear the speakers better. And while the speakers are presenting their talks, you can also raise questions in the chat box, which will be taken up later in the Q&A session. So without taking any further time, I would now like to invite Dr. Girija to share her experiences and perspective on the theme of environmental and health impacts of persistent organic pollutants. Over to you, Dr. Girija.
Thank you, Suparna, and thank you everyone for this opportunity. Working in this area of persistent organic pollutants and many contaminants has been a great experience for me. For about 15 years, I have been working in this area, and it started basically when I was working in US doing my postdoc, and when we visited many of the areas, many of the rivers, we could see that some stretches of the river were shown, were having this information that the fish collected from here should not be eaten by infants. And
Dr. Girija, can you hear us?
this was, nor does it exist in India even now. Very, very pertinent for India, with large population being impacted, especially children, to and exposed to persistent organic pollutants, many of which are endocrine disrupting chemicals. That's when the research started 2007 and then continued till now. We have done a large number of many rivers, Ganga. Right now we are doing Tapi River in Gujarat, Daman Ganga. And I am really blessed to have an excellent professional and a great friend to work together and ideate on our next moves and what we are doing together and how we can take it forward. And I'm really happy that she is here with me as a co-panelist, Dr. Paromita. My presentation will be basically touching upon the pollutants, the properties and the environmental impacts, and how impacts wildlife, human health, and EDCs, how it is impacting human beings, children in particular, and some case studies. So I know my time is limited, 15 to 20 minutes, so I'll not go into much details of everything, but then I'm happy to take questions if I miss anything here after the presentation. Pollutants, in fact, enter our daily lives through many sources. We use pharmaceutical products, personal care items. Many of them have some POPs or the other. We call it as persistent organic pollutants as POPs, which have been added to the product to increase its characteristics. Some are flame retardants or surfactants or other uses. The problem with them is they do biomagnify throughout the food chain and bioaccumulate in organisms. And even at low levels, these persistent organic pollutants are very injurious to health, of human health, environmental health, animal health. We consume animals like fish, chicken, and others, and it gets deposited in the fat. They're basically lipophilic. And when we ingest this food which is contaminated with POPs, we have it in our system and we do pass it on to the next generation. So as I mentioned, persistent organic pollutants, they do persist, they are resistant, they resist physical, chemical, and biological degradation. Bioaccumulative, they have semi-volatile characteristic because of which they evaporate relatively slowly with warm air and get deposited in the colder regions. And they have long-range atmospheric transport. That is, they go a long way and get deposited in our glaciers and in our polar regions. So this will show you a bit of information about what I was mentioning. From warm regions, they get and have a tendency to deposit at temperate regions. From temperate regions, they have a tendency to go to the polar regions. So this is called a grasshopper effect. And some of them which are very highly volatile, they do directly from the warm emission areas, they go to the polar areas and beyond. So increased evaporation from the warmer areas to the colder areas. So there is a high concentration of these POPs in Arctic animals. They are carnivorous, that is, they are high end of food chain, and it stores energy as fat for survival in extreme climate. And as I mentioned, POPs is lipophilic and it has tendency to get transferred from intergenerational. That means from mother's milk, it gets transferred to the infants. The ill effects on wildlife is it is causing reproductive impairment and malformation. It impacts the immune system, altered liver enzyme functions, increased risk of tumors, and risk of porphyria. Mammals, birds, reptiles, fishes, invertebrates, they all get impacted by different POPs in different ways. For birds, the eggshell gets thinned, and because of which it has a tendency, the egg doesn't form basically, it has a tendency to break, and then there is decline in the number. Similarly, in the case of reptiles, there is decline in the number of alligators. We have seen these case studies like the Florida case studies where organochlorine spill was there, and we have seen a drastic decline in the number of reptiles. In the environment, well, DDT is one of the POPs. We have in persistent organic pollutants, we have about 30 POPs now, which comes under the Stockholm Convention. DDT is one of the main POPs which has been allowed in India for reasons like malaria control, but we know that DDT has been used for many other purposes than malaria control. We have seen it in being sprayed in agricultural field. It does impact the agriculture, it does impact the groundwater, it does impact the persons, because in India we do not have sufficient safety mechanisms in place, sufficient safety gears, and the people who are exposed to this, they carry it, as I mentioned, intergeneration. So DDT was found in several water bodies in India. Our studies have shown that soil, even groundwater. Polychlorinated biphenyls, that's also one of the PCBs, and organochlorine OCPs, pesticides, which has been found in river Brahmaputra. I'm sure Paromita, this is her study, which has shown this. And various studies have detected different persistent organic pollutants, many of them in Ganga, Yamuna, and many rivers. Right now, as I mentioned, we are taking a study in Tapi River, the Manganga River, and we are analyzing it. In fact, Paromita is analyzing this water, sediment, fish, the milk pollutants in this. We all consume it without any proper mechanism or framework, legislative framework available. Milk products, as I mentioned, has a great tendency of being contaminated with persistent organic pollutants. About as much as 80% of the dietary intake of pesticide residue is there in dairy products. So the modes of human health impacts are different, like ingestion is one, inhalation, dermal contact, occupational exposure. So there are multiple routes of human exposure, and the exposure to POPs can result in endocrine disruption, reproductive and immune dysfunction, brain and nervous system disorders, many kinds of developmental disorders, genotoxicity, and birth defects. Many of you would be knowing the story of endosulfan in Kerala, the Kasargod tragedy. These are big wake-up calls that persistent and organic pollutant not be taken lightly. We should not wait for a bigger tragedy to happen and then have regulations in place, because it's the body burden of POPs is very, very high, and during fetal programming, the changes are permanent. The damages are permanent and irreversible. If somebody, the timing of exposure is very important, and if someone is exposed during adulthood, homeostasis compensates it. But different life stages, the effect is quite different. And the type and severity of effect is extremely important and not to be neglected. As I mentioned, the effects may appear later in life, even if you are exposed to it early during the early years of development. So the exposure through unique routes like breast milk, transplacental, etc., are very, very important ones to be safeguarded against. Our children, we are exposing our children and the next generation to a huge risk if we are being silent on these endocrine disrupting chemicals. Many of them are persistent organic pollutants. Some of the endocrine disruptors are like bisphenol A. You must have seen this labeling of BPA-free bottles in the feeding milk. In fact, our colleagues, feeding bottles, our colleagues from Toxics Link, they had created a huge hue and cry and done a lot of policy advocacy, and our feeding bottles were banned. And now you will see that bottles are written BPA free. So these are science-based policy advocacy measures. So I'm glad that we are all working together and we are generating awareness among the masses, among the policymakers. So some of these endocrine disruptors, such as bisphenol A, the sources are like plastic and thermal receipt. Thermal receipt is that ATM paper which we get, that also is coated with bisphenol A, BPA. Phthalates, in fact, Paromita has just got published another paper on phthalates, that plasticizers and PCBs and brominated flame retardants. So these endocrine disruptors are entering our households and we are being very negligent about it. So there has to be measures in place to see that that alters function of endocrine system and consequently causes adverse health impacts. As you see in this picture, it mimics the endocrine disrupting chemicals, mimics the hormone system and causes adverse health impacts. I've already mentioned about this, so I'll not go into the details of this. This is how the possible modes of action of EDCs are. They basically bind to the estrogen receptors, damaging DNA. They increase the endogenous estrogen levels by altering aromatase. And you'll see from normal cell how it progresses to a tumor, how it progresses in the form of tumors. So EDCs may influence any of these hallmarks. So you will see slowly the tumor becomes cancerous, and that's how EDCs impact the system. The key concerns are very high incidence of increasing trends of many endocrine related disorders in humans is seen. Obesity, diabetes, etc. are some of them. Endocrine related effects in wildlife population has been seen. Chemicals with endocrine disrupting chemicals is linked to disease outcomes in many laboratory studies. However, disease risk due to EDCs may be significantly underestimated. Just a few more slides. I know I am taking a little more time. We have seen in our studies in Ganga, from Uttarakhand to Ganga Sagar, Farakka and Ganga Sagar, that the surface water contamination and groundwater contamination has a very significant correlation. And these EDCs, many of the persistent organic pollutants are available in surface water, and they are also available there in groundwater, which is basically drinking water source. Recently, we have done, in fact, our study is still going on, where we have collected food samples and seen that many of the food items are having very high contamination. The samples were collected from Delhi, from all the zones of Delhi, and compared with the food items of Uttarakhand, that is Dehradun, and we have seen many of the heavy metals being there in spinach, milk, paneer. These are the food items which we think are benign, but they are unfortunately having very high level of contaminants. Paromita will speak more about the studies which we have in fact done it jointly, and I will not go into the details of the studies. In conclusion, India has actually a very comprehensive apparatus of environmental laws. However, lack of an integrated system and regulation of chemicals is observed. Poor management of pollution and the fundamentally retrospective vision has resulted in ineffective implementation of laws. Sorry to say that, but we need to really work a lot on that. Our laws are there, our systems are not so much in place. So there is huge challenge in this implementation and integration of these regulations of chemicals. As an industrial and technologically advanced country, we cannot afford to be fence-sitters. We have to jump in and see that our quality of life is not impacted by pollution. The retrospective approach which we are having in the pollution management really needs to be replaced with a more prospective approach, with policies being informed by scientific knowledge. So there is a long way to go for us to work on it. We have generated a number of policies, papers, number of research publications, and some of them have been given as recommendation to the governments. Let's hope there is some headway in this. With this, thank you so much for your patience.
Thank you so much, Dr. Girija, for taking us through, the details of the properties of these emerging pollutants, scientific knowledge on that, what has been the policy advocacy efforts by different organizations and your own efforts that you're making, and also the key concerns that we can work on in the future as well, jointly. So thank you so much. Without taking any further time, I would like to invite Dr. Paromita Chakraborty to share her experiences and perspective on the theme of water health nexus for endocrine disrupting chemicals based on her research, and what are the new challenges that are related to the ongoing COVID-19 pandemic. Over to you, Dr. Paromita.
Hi, thank you very much for this invitation, and definitely it is a very big opportunity for me to deliver this talk today. I'm really thankful that Dr. Girija already briefed EDC, so it's like coincidentally I'm taking up from where she left it. So it's interesting. As we all are aware of the fact that water, very, very essential part of our life, and the major source of water, the drinking water, is the fresh water. And the fresh water is something that is needing a lot of attention. We would be having huge crisis. Actually, the pandemic has increased a lot of problems which we already had. So I'll take you to this story, like what motivated us to do several works. Like water, that fresh water sources is always being misused, or like we dump a lot of our waste, especially in terms of agriculture or industrial waste, or even the household solid waste, many a times end up in the freshwater bodies that we have in our country. So that is giving us a lot of crisis. So that is the basic motivation for a major part of our research. And if you see, just not this kind of waste, now the upcoming waste is the plastic. The plastic that is hugely like used by across the globe, and then it is ending up in the surface water or riverine or marine belts. So that is also creating a lot of hue and cry, and then we need to understand where do we stand. Now, the major problem statement that we have, like this is some of our works are proving that open burning of the solid waste, which is a very, very big challenge for us. And, you know, every time I come to school, every day almost, I'm recording a lot of stuffs and, giving us a lot of new ideas, how to go ahead with the research problems, that this openly burned waste containing the plastic component, you see, these are all the photographs we are taking. We are working in the dump sites, or when this waste, it's like, this is the condition just before it is being burnt. Within an hour, the condition is like this. And you see a lot of waste material, including single-use plastics, are ending up in the riverine belts. And that is a very, very big problem that we will have to take care in the near future. So with this, the outline of my talk includes like, what are these EDCs? I'll not go what Dr. Girija already has explained, but what would be the sources from these areas? And then how we are seeing those in the water bodies, little bit of our case studies and something that is happening across the globe. And we are taking up certain sustainable approaches to understand and how to combat the problem. So all those like studies are like just briefing you in the form of a story now. So WHO, and has come up like with a joint program with UNEP, that there are thousands of chemicals that are coming and we are using for different reasons, which are endocrine disruptors. And then it can have, and if it is, attacking the hormones, it means hormones takes care of every functioning of the human body. So which means it can lead to several dysfunction of several systems. So whether it comes to nowadays we work with infertility work, or in terms of diabetes, or heart diseases. So this huge number of chemicals has to be arrested properly. And that's what possibly, our team and Dr. Girija's team, we are working on it. So this endocrine disruptors, like what do they function? We can categorize, as Dr. Girija already mentioned, so I'll not get into the types like pesticides or personal care products, or some pharmaceuticals, or some kind of organohalogens. Even heavy metals are one of them, or plastic additives. And now Dr. Suparna already mentioned about plastics and microplastics. So we would be seeing like what we are actually working on. Now, plastics again, like, as we were discussing, like plastics are there everywhere. So what is the connect between this EDCs and plastics is what I would like to take you in the next few slides. Another arena which I would like to highlight, we have been doing a lot of work. We published like a couple of papers and 2 projects funded by Indian government. The electronic waste, more than 95% of this electronic waste, which majorly consists of metal, 80% plastic. And this actually ends up in the open dumps or even in the riverine environment. And then again, the metal recovery is taken up by the informal sectors. So during the process also, they are releasing a lot of contaminants. That's a different story. Maybe we can save it for some other day. But these are also releasing a lot of contaminants. And when we are talking about all this, consumer gadgets, or anything that we are using in a daily life, we are also using a lot of flame retardants, a lot of plastic additives when we are making a product. So basically, when we say that, plastic is bad, can we really get rid of it? Any chemical, even that matter of fact for DDT, when DDT, DDT came up, it was saving lives. But again, when there were other, now we feel like, okay, what is the, disastrous impact of DDT? But again, we need DDT, like countries like India or some African nations, to combat the vector-borne diseases, to immediately arrest it. So we have certain sectors. So similarly, flame retardants, which are novel or also emerging contaminants, these are also creating a lot of problems, especially when we are mismanaging the waste that is coming to the solid waste stream. So these electronic gadgets, again, can have a lot of flame retardants apart from other household stuffs that we are using every day. And also the chemicals, the plastic additives to give shape to the plastic products, those could be equally important. So with this, what we see is this lot of plastics and microplastics are there in different parts of the environment, whether it is in the, it comes from the terrestrial, some portion can lead to marine, and when we are burning it, some we are getting in the atmosphere, and from freshwater to groundwater. So it's like the entire globe is actually having some bits and parts of this plastics and microplastics, which is again coming from different segments. And ultimately, when it comes to the riverine or the aquatic or even the marine belt, which is a major source of productivity. See, 3 part of the earth is water, and first 200 photic zone is the main productive zone of the earth. So there also this microplastics are getting in. Why? Because of the macroplastics, and within long term, it can get just fragmented. It cannot be, removed, or it cannot be degraded. That is a serious concern nowadays. Microplastics being just, I wanted to share the slides, like to understand, like what is the size range, if you put a 5mm scale. So it can go from few nanometers to few millimeters. And we are again very much concerned about different kinds of polymers that are coming up from our daily to daily activities or daily whatever products we are using. This is Harley Reschel is one of our collaborators. Very, very interesting work that they have done across the riverine or aquatic environment across the globe. And then the model part, like what is the quanta of microplastic that is getting distributed. So, and not only in the surface water, but sediment. With the production, there is also, as the plastic production increases, this quanta would also increase in different parts of the world. But then what happens, like not only just as a micro, but as a macro, then a lot of aquatic organisms can also take it up. So this is another way that, all the products that we are using in the terrestrial surface are ending up in the marine surface. We are not just affecting us directly, but also indirectly, because sometimes when this marine organisms, many of are fond of non-vegetarian food. So that is again an indirect way to come it back to us from where we are releasing it. But now, one important question that I have always in mind, and we are as a whole, we are trying to understand, it's not just the plastic as a matter. The plastic that is there, it has a lot of chemicals inside it. And in the natural environment, whether in terms of like when it is there in the water, or when you have like the temperature plays an important role for a lot of degradation of those material, or when it is coming up, or it's mostly like not degradation of plastic, I mean, but some of these chemicals can degrade it in different environment. And then the degraded product, especially for persistent organic pollutants, these are more toxic, even more toxic than the parent isomers. So that makes the situation even more complicated. And what happens in an ecosystem, if those weathered plastics, are releasing chemicals, and then the chemicals are there in the water, then indirectly it's impacting us. And the tiny plastics which are getting into the fish bodies, again, that can have a long-term impact on us, because again, many of these contaminants are lipophilic, so they get deposited in the tissues, the fatty layers, and that can have even more severe impact due to bioaccumulation. This is an interesting paper with a model paper which is talking about the quanta of plastic that is coming in. If you see that in India, especially the Suli region, and also the other region, that other side of the map where we are catering to now, close to Arabian Sea near Gujarat and Mumbai belt. These are the areas where the loading is, they have done a kind of model study. So the loading is much higher in this two particular belt, Bay of Bengal and Arabian Sea, the mouth. And if you see, like with this, the model, we are also, if you try to figure out like the amount of global plastic production and the chemicals that are used in the plastic production, it has increased quite high. And we, like after United States, China and India are the major chunk that is producing for different kind of products that is coming up. So almost all the consumer product we have, more than 85% of the product we are using are actually made up of plastic, you see all around. Now, this is under the Stockholm Convention that POPs are being regulated. So if you see that there are certain compounds which are in the eliminated form, some are restricted, some are unintentionally released, and some are yet to be confined, or they are still in the process of release, and we have to control those. So there are legacy contaminants and emerging contaminants under the category of this persistent organic pollutants, which are persistent because, like plastics, that they cannot be degraded. So if these contaminants are there in the plastics, that creates even more horrible scenario. And imagine when we are openly burning those, what we are ending up. So what in my group, what we are doing is we are trying to understand from the hotspot, how these materials from different hotspot region it is emitting. It is going to different layers of the environment, including the water, surface water, groundwater, and also the atmosphere, and how ultimately it's impacting the human health. We are also understanding the emission inventory from certain compounds and the long-range atmospheric transport. The intermediate movement of these compounds are very essential to understand where after release these molecules are ending up. And we are also trying to find out like if there is some cost-effective remediation for this kind of molecules. So while we are targeting all those, again, most of these compounds that we are targeting are endocrine disruptors, like they are mimicking the hormones. And they could be even carcinogenic in nature in the long term. The steroidogenic molecules needs really, really serious attention. Now, what happened during this pandemic phase? Can we highlight some more important points, like what we need to think about? We had an interesting project where we were doing, me and Dr. Girija together for the wastewater surveillance. We were trying to track SARS-CoV-2 and estimate the number of infections in the catchment Chennai city. But with that, we also, what we had in the plan, let's do more of the pharmaceutical compounds also, because people would be using more in amount. And what interestingly we found in the riverine water bodies, like it was the loading of the viral particles were also having those areas where a lot of endocrine disrupting molecules, especially used as antibiotics, were pretty much high, especially in the low income group areas where even the viral loading was more. So possibly if people are affected or impacted, so let's say, for example, azithromycin is given. So we found a good quantity of azithromycin in those regions. So this can, again, some of those pharmaceutical molecules, which can also come as an emerging contaminant. Apart from that, now again, I'm diverting you back. Those are the pharmaceutically active compounds. But when you think about the plastic, we are using so much of masks. We are using so much of plastic products. Pandemic has given a huge usage, but are we recycling those very well? And if you see that this is the even reporting talking about that, we the amount of plastic mask, it is more than 89 million plastic medical mask and 1.6 million protective goggles that are coming up. And then it can take more than 500 years to degrade. And they are saying that Asia Pacific region will have actually more issues because of the kind of, the plastic waste management that we have. It can be a really serious problem. Now, this is what we were seeing in the reports, but as Dr. Girija was mentioning that we are into a project. So what we are seeing with this project, with this project, is you imagine these plastics. Okay? They have, when we are making the structure of the plastics, we are using a lot of chemicals or plastic additives, which are lying on the chemicals, on the polymers, just in a mechanical way. Like if there is any weathering, these chemicals would be released. So these chemicals, along with the plastic, these chemicals can easily come out in the system. What did we see? This is during our, Innopol sampling in 2020 December. You can see here that what do we do is we dumped all kind of waste, including the plastic waste. This is in Chennai city, this is in Vapi, and the openly dumped areas wherever we went. And then you see that the plastics, the masks, everything that is being loaded coming into the open dumps. And these are not utilized dump sites, I tell you. It can be dumped everywhere, all along your household, or like, on the street, it is happening, and people are quickly burning it. So then, apart from existing load, the pandemic also has given us higher load of plastic waste. This needs really, really serious attention. Now, what happens? What do we get out of it? So different kind of plastic material, when we are burning it, incomplete combustion, all these chemicals, these are flame retardants, or it is plastic additives, or which have different kind of contribution in this, in terms of EDCs, or even in more harmful contaminants, then they are coming to the environment. And then we are looking into this kind of plastic and POPs interlinkages. How do we see those, and what are actually coming out? So with this, we have come up with a very interesting paper wherein we are talking about, like, what is the different kind of material that can come up when we are burning this, and during this time. Like, we don't need a newer source, but again, new source added can have even higher quanta of problem in the future days. So we were looking into different kind of organic micropollutants in the lower stretch of Ganges, and we found that the plastic size of plastic additives, if you remember a few slides back, I was showing a model data, that lower stretch of Hooghly, where the model data is talking about, like, more quanta of plastic being ending there. So we saw like much higher loading among all the organic contaminants, most of which are emerging contaminants. We saw plastic additives were the maximum ones that were loaded. Then what we did, we took the entire stretch of Ganges, nearly 1700 kilometers we covered, starting from Haridwar and the Bay of Bengal, and we also catered to Sundarban wetland. And we found that in the industrial areas, and especially certain plastic additives in the tourist location, which is associated with the PET bottles. So PET bottles which are used up and thrown away, and those tourist locations were showing high quantity of certain plastic additives associated with the PET bottles. So this means, like, again, improper disposal. And we also use this, like, as I said, like, these compounds can mimic the hormones. We expose this concentration into human cell line, and we found, like, certain areas in the middle stretch of Ganges, the toxicity was actually much higher than the expected range that we should have, which means, like, they are actually mimicking. And we also analyzed steroids in those sites, steroids which should be acting like, estrogenic receptor, but we didn't find steroids in those samples. So that was an important point that we had in published last year. And again, during this phase, what we are seeing, it's not the water. There is also emission of this when we are burning this, atmospheric emission of these contaminants. And in due course of time, it is possible that this atmospheric contaminants can actually undergo atmospheric deposition on the surface water body when there is monsoonal rain. So this plastic additives, again, which are in this wastewater stream, they can also end up within varied plastic, packaging material, or even when groundwater is contaminated, and we are using the groundwater for production of food or varied purposes, or even plastic mulching in certain areas could be a source, even entering to our food, so which can actually impact our health as well. And we have, again, this interesting study where we have seen that the food from a very urban center in Delhi was having much higher loading of plasticizer, and the plastic material, the packaging material, were a source of one particular plastic DNBP, which we also seen in the plastic material, that is the packaging, for packaging products of, like, say, paneer or milk packages. So this again says, like, if you are using those plastic products or during the processing times, which could be there mostly in the metropolitan environment, more packaged food are available, they might be more exposed. Although these levels are not crossing any limits that is given by the international organization. And we have also seen another interesting part, like the bottles used with recycled polymer can release more quanta of this plastic additives. So that is, again, I won't be mentioning the name of the brand, but I'm just telling you, like, the one recycled polymer means the one that is like 10 rupees or 15 rupees bottles you get here and there. And if they are there in the sunlight, please don't drink water from those bottles because they are not made from recycled plastic. So those polymeric material can leach much faster compared to the higher brands who use pristine plastic. And again, as I was telling you, that some of these compounds can undergo long-range atmospheric transport. Dr. Girija was mentioning most of the POPs. Yes, this plastic is having varied compounds which can undergo long-range atmospheric transport. And then finally, what happens? They can even deposit in the pristine regions, like upper ranges of Himalayas or Brahmaputra, where it is not even being used, or it's completely pristine, but we are still impacting those regions, or whatever we saw in Sundarban wetland also. So what are we doing? What is our future plan? As I told you, we can have this EDCs, different sort of exposure. The pregnant mother exposed more. We are having a new project on that. And then coming to mother through the placental transport, and also the human milk, because these are all lipophilic compounds. The human milk is also a major source. So not only just water through fish, the diet, the atmosphere, the inhalation part, and whatever we are having the dermal contact in certain cases when you are using certain products. So we are exposed from variety of ways, and then it can lead to a very, we are actually exposed to a cocktail of pollutants, cocktail of EDC, and that is actually a very, very serious concern. So what we are doing in the ongoing projects is, one is we have our own medical school. We are looking into the, the placental transfer part and the human milk concentration of this kind of contaminants, which are lipophilic in nature mostly, and this kind of things. And apart from that, we are also trying to come up with new design of recycling plastic. So we have a patented product wherein we have replaced the casing of a wooden pencil with recycled polymeric pencil, and this is also commercialized. So we are using valid plastic product for recycling purposes. We are also trying, a prototype is getting ready, where we are, we are using food waste material to make bioplastics. And we are also using this plastic to make paver blocks. That is also an interesting part. These are all new stuffs we had been doing since last year. And so these are the things that we are doing, a sustainable approach to take care of the plastic that is coming in the environment and to stop the chemicals. I don't say this is a solution, but this can expand the life of the plastic. Immediate burning can be stopped because we are giving value to the waste material. And we have some 10 years more to do more research and find out a better solution. If possibly we can do that, I'm not sure. And also to take care of the water part, what we are doing is, this is again another, we are planning for patenting it. Like we are using adsorbent like biochar from the sugarcane bagasse. We have different molecular characterization for the char, and we are using a lot of composites to clean this wastewater that is coming to the system and containing this kind of EDCs. So when we are taking the filtrate through this system, biochar augmented constructed wetland, we are getting water and we are testing it, and the levels are either going down, or in some cases we are not seeing the levels because these are in ppb levels. We need a better technique, better adsorbent like this to remove this kind of contaminants from wastewater and to get the fresh good water, better water quality. So that's what we are doing here now. And we're also going for outreach programs. So this is like before Chennai flood, and every year, 2nd October, I'll go with my group and figure out what are the real-time problems and what can be solved. You see here, like the water is coming, drinking water is coming from a pipe below the drains. And when there was flood, I was actually visiting these areas. These drains were flooded. So you can imagine, like there are a lot of questions to be answered, real-time questions, and a lot of having societal impacts. And this is how we are trying to encourage our young minds to come into research and do something more for the society. So with this, I would like to acknowledge our InnoPol project, which we all are doing. You can see me and Dr. Girija, like as she mentioned, started with our collaborative network, and that's how we are working together. And this project is giving us a very good dimension to work in this area. So I must acknowledge the project. And we have a lot of partners also in the project, that is from Norwegian Institute of Water Research, TERI, and CIPET and Toxics Link, apart from our 2 organizations. And definitely I have to thank my research group. We very actively get into the research part. It's not so easy to just collect samples and do the analysis. Like, it's a very tedious process, and then do the modeling, then try to play with the data. So my entire team, excellent super team I have, and we really enjoy doing work all through. And thank you for listening to me for this. And if there's any question that I can take up, I'm not sure if I took extra time. Thank you.
Thank you so much, Dr. Paromita, for sharing about your research and all the effort that your team is putting in, not only to build knowledge on direct and indirect impacts of these contaminants, but also giving us hope. What are the sustainable ways of removing these pollutants? So thank you so much. And now we have the discussant, Miss Aradhna. She will be asking some of the questions. Yeah, Aradhna.
Yeah, good evening to all. Very insightful session indeed, and like a combo for a common man, and those amateur in this field has a very good got a very good knowledge to this session. So my question related to this part only, the thing which is intrigued me most to this session, like when ma'am was pointing about DDTs, and when we're talking about BPA and endosulfan pollutants and the negligent attitude of the government. So my question is, what can be done for a role as a youth in addressing the issue of emerging pollutants in water, like creating awareness, develop innovative method techniques? What are your views, ma'am? The question is for both you, ma'am. For both of you, ma'am.
Thanks, Aradhna, for asking this question. There are multiple ways of addressing these issues. We should not be only saying the government is not doing enough. The government on its part is doing quite a lot, but then there is still scope for doing more. In 2018 March, the government came out with the Ministry of Environment came out with a gazette notification that the new persistent organic pollutants, that is, earlier we had the POPs, which was called dirty dozen, that is 12 persistent organic pollutants. And in 2018 notification came out with 7 new persistent organic pollutants to be banned or phased out. But the issue is, how well is that monitored? Because when a chemical comes, it comes with many hazard questions. But then by the time the research develops implications, so much of harm would already be done. So for that, we have to take a prospective approach, preventive approach, rather than a retrospective approach. Like in Europe, they have this regulation called REACH process, which goes, so not so much of damage is done by the chemical. We have to have something like that, which is prospective approach. Stakeholders are extremely important, because for businesses, they get into business for profit. They don't give importance to the environmental aspects and the health aspects. That's extremely injurious to the society. So stakeholders are extremely important. General awareness is important. So it has to be like multifaceted, not just one. So people and the policy and the programs, everything is should be well integrated and well orchestrated.
Thanks. Thank you, ma'am. Ma'am, Paromita, ma'am, do you want to put some?
I just want to add one more point, like as Dr. Girija rightly mentioned. And one thing is, I would tell you a little bit about the nature of the molecule, like endosulfan, when we brought it. See, when we were going to, during my first year, when I just came from US and started my own research group, we visited Kasaragod. That was my first aim. And I remember, like, what we saw is, like, endosulfan areas, the cashew plantations were removed, and then they have started with the rubber plantation. So the soil it's a new soil, but there is lack of little bit understanding, because we don't get into much in India. Environment means planting trees, but there is a section called environmental chemistry, so which says, like, this endosulfan, if it is broken, the isomers breaks down into endosulfan sulfate, which is even more toxic. And that has even more deleterious impact. So when you keep a layer, and then this can undergo atmospheric transport, interesting part is endosulfan that is used in Kerala or Kasaragod, for example, at a certain time, we were using atmospheric trajectory line that during certain time of the year, atmospheric transport is bringing these molecules all the way to Porto Novo, which is a fishing village in Tamil Nadu, because of the coastal atmospheric transport. So these kind of informations are also very essential, which European Union or even other Asian countries like China or Japan are doing extensively, that they're trying to understand the molecule doesn't end up there. So we have to do a constant monitoring or modeling of these molecules unless it is completely phased out. So that is also very, very essential. We need, a lot of participation in terms of government projects, or even, a lot of information should come out. And those correct informations, if it reaches the government or the policymakers, I think that helps them to decide it better.
Ma'am, my question again came from this point, and you have given some sustainable solution which you have devised, as a part of your project. So there's information how POPs absorb by the soil and water and causing ill effects, and suggestions are also provided, like you have given in your presentation. So how cost effective it would be and how safe it would be. So can you please share a thought on this? Because we have to convince policymakers for those approaches. So how safe it would be?
See, one thing we have to understand, all these contaminants, what we are getting, it is in parts per billion level. The levels are very low. Why we are actually not doing much research is, in developing nations, we are struggling with those contaminants which we can see visually. Say, for example, if the water is dirty, you can see it and immediately you want to clean it. So that is a problem. But when the water is clean, but there is something inside which needs a lot of high-end instrumentation to understand, because this is in ppb level. You cannot use spectroscopic methods, but you have to use spectrometric methods to understand this in ppb levels. So in those cases, we have to, if in ppb levels means, cleaning that water, surface water, wastewater is to some extent, if the quantity is more, for certain compounds, of course we can, but POPs again, mostly in ppb levels. So then it was instigating me, like, how do we handle the problem? And then given a country like ours, we need a cost-effective technique. So wastewater, wetland, constructed wetland is always a very, very good effective technique to hold on the pollutants. It will not allow to get into the, groundwater. So now what was the idea? If we can have another add-on adsorbent augmenting in this constructed wetland, what we are doing is, we are just trying to hold on the contaminant for some longer time, and then when it has concentrated to one point, we can take this part section of the the constructed wetland or the material and the adsorbent to go for some other high-end technique, because now it has adsorbed, now it has come to a concentrated system. So this is what we are trying with Mantra Pot, which is like a biochar augmented constructed wetland. Biochar, many people use this, but we are refining it. We are trying to come up with our own composites so that we can get a maximum efficiency. So what happens is, again, I said, it may not control the complete problem, but to a greater extent, we can hold the problem to a segment instead of going to directly to the drinking water sources or the fresh water sources. So this can be a very effective one. Say, for example, if there is a endosulfan manufacturing belt or DDT manufacturing belt, they can very well have this kind of idea. They can throw their waste material through this belt, and they can allow the material, like, the water to fresh water to come out of that segment. So at least we are coming down to very low levels, so the exposure can be reduced, if not completely eradicating the problem. That's what we are trying to do in this work. Yeah.
Thank you so much, ma'am. Girija ma'am, do you want to add something on this?
I think Paromita has very comprehensively mentioned that, and completely agree with her viewpoint. Yes.
Thank you, ma'am. So, ma'am, we are focusing on POPs in land and water, as you have rightly pointed out how it flows in the environment and atmosphere. I, who live in city of Hyderabad, who is a city of pharma hub, so we people are agonized with the stench of the smoke emitted by these factories on and off on regular basis. So, what are the ways these issues can be resolved, and how it can be approached, considering the importance of pharmaceuticals in the health sector and the wastewater generation? So what are your views? How we can approach this problem?
So, yeah.
In fact, wastewater reuse is a big area, and as Suparna had read out my bio, where she mentioned that I am involved in developing the national framework for reuse of wastewater. Here we have a lot of hidden contaminants. These are not, we can't visibly see the contaminants, and it's extremely important that we use or reuse this water with caution, because if there is issue in like if it looks dirty, as Paromita mentioned, then we are wary of it and we don't use it. But water which comes in our taps, we have seen that certain places the microplastic has been seen in this tap water. Certain places we have directly, people consume directly from the groundwater. So we are unknowingly ingesting different types of contaminants. So it's extremely important that pharmaceuticals and personal care items, many of them are there in our water, many places. And we have to be extremely guarded about how safe water we are consuming. The municipality has a big role there. The government has a big role there. And we as aware citizens should also see that we generate this awareness among people. Yes. And we researchers, we do bring out data and inform through policy briefs and discussion papers the governments, and many times the government really takes action. Yeah. Paromita, you would like to add some from your side?
Yeah, again, I would like to talk about the major problem with the pharmaceuticals. It is not just India. Across the globe, we have issues with the pharmaceuticals because, say, for example, I usually go with the number. Say one person taking azithromycin during this COVID pandemic period. Say you are taking 650 mg or 500 mg in a day. Say you are taking 1000 mg. Now 60 to 65% will come into the wastewater treatment in the raw sewage. Now treatment plants across the globe are not designed for pharmaceutically active compounds. And again, I'm telling these are in PPP levels. So it is not possible. They are not well equipped. And not only just in developing economies, even in developed economies, it is not possible, which is why what happens after treatment, say even 70% is removed, whatever 60% has come to raw sewage, still the 30% can make nearly 100 gram of the 100 milligram of the 1000 milligram you are taking, one person is taking one day. And imagine a catchment of say 4 or 5 lakhs population. What is the quanta that is coming to STP? So if the STP is not able to treat it, it will go to the surface receiving water. And which is why antimicrobial resistance is going to be an even bigger problem than the current pandemic. So the scientists across the globe are trying to understand how to deal with this problem. Not all problems are developing economies problem. It's also a problem for the entire globe. And monitoring devices are also lagging in many cases when it comes to surface water bodies. Apart from that, we have also another issue that we are having in many river systems, even in the Ganges, there are direct discharge points. So, I mean, it may look little, how to say, it's like a dream, but I wish, from the direct discharge points, if every place we can pass it through such a by augmented constructed wetland, if not otherwise, just through a constructed wetland, which will beautify the area, and possibly we can hold on certain contaminants to enter directly or some amount before getting into the receiving water bodies. So this is another major problem. And it comes to surface water means there is chances of penetrating in the groundwater as well, which means we are taking up with our drinking water. So ARGs or pharmaceuticals in this manner, it is not across the globe. We have to understand it better, and we have to design certain ways how we can handle it together, or even equipping the STPs. In this regard, we have come out with Kefin. Kefin is not a pharmaceutical compound, but it's a good chemical marker, which we have seen that it is associated with the quanta of human waste that is coming up to the wastewater channel. So such markers can easily help us, like what is the quanta that we might be seeing from the STPs or the discharge points, to track the discharge points, and then we can figure out a solution. So such kind of a projects actually are very much needed, even in a pilot scale, to improve the water quality in different parts of our country, and also possibly across the globe.
Suparna ma'am, please give me one liberty. You know, as a discussant, I have taken a lot of liberty to ask so many questions. Just a last question to both you, ma'am, because you both are working in this scientific field like more than 3 decades now. So as I understand, there is a relatively less representation of women in scientific research as well as industrial sector. Could you please share your thoughts as women scientists and any suggestion to young women entering in this field? This is my last question. Then we can take questions from the chat box, ma'am.
Well, I have never faced any gender discrimination wherever, be it school or university or workplace. But then women themselves do not, I feel, enter into STEM areas, that's science, technology, engineering, mathematics, and in the research. In fact, just the other day, I was talking with my first PhD student, and he said something which was very disturbing, which I also thought. We always think we are being discriminated. Let us change the narrative. Many girls who enter as PhD scholars, sorry to say that, I don't say all, but many, they use this as a matrimonial tag. And once they get married, they just leave PhD or dump it, and the scholar, the supervisor feels very frustrated because the supervisor also puts a lot of effort. Unfortunately, when I was going for my PhD, I was asked by my supervisor that, will you leave it after your marriage? I said, definitely not. So not many girls have been consistent with that, and they leave the PhD, and that's why women are less. And after a certain time, they get back to the research and etc. So we see a lot of leaky pipe and sticky bottom syndrome in women. And women are very tenacious when we do PhD. Like I remember Paromita and I, when we were working together in the laboratory, from morning 8 a.m. to 11:30 in the night, we don't even feel tired. It's so contagious. We really enjoy working together. And I don't know why women do not participate. So we should not say the system is not enabling. Women themselves do not probably have the drive. You say the fire in the belly. So I see that less in women. That may be the reason. My PhD student, he was saying the same thing. And I get to hear from many of the supervisors this issue. So women have to basically take charge. Women are here to make a difference. Women should not think we are optional. We don't need to. But once they get into the arena, they have to exert themselves. They have to make a difference. They are here to make a difference. Sorry for being a very long answer.
Thank you, ma'am. Yes, ma'am, we have to change our attitude first. Yes, ma'am. Ma'am, Paromita, ma'am, you want to add something?
So far, I try to have equal number of girls and boys in my research group. And I always tell them, like, even girls have to come to the field and boys like in the same manner. Nobody is going to help anybody. So I try to keep it clear from day one. Fortunately, so far, even if sometimes some may show some inhibition, but after some time they get too much of interest, like when they do it individually. So I didn't face any issues so far, and actually my girls were doing a little better than the boys. Sometimes they will fall sick, but girls were pretty stronger sometimes. But as Girija rightly said, yeah, I know many of my colleagues also complain a similar thing, and especially, but these are different circumstances, and and also one thing I would like to say is that Indian government has given a lot of opportunities for women who have taken a break. Like just now, I've considered one lady. She has taken a break for 6-7 years from academics because she wanted to have a family life. And OSA B, like, DST supports, they fund projects. So if really women who have taken a break and wants to come back to science, it's a good opportunity. And I think many mentors, like many of us, we would like to give them an opportunity, and they have to make the best use of it. Because see, end of the day, we are running projects. And if we are running projects, we can't help to doing on time. We are taking taxpayers' money. We are very much responsible to what we are doing. So we cannot just let things go. No matter it is a boy or a girl, I feel they have to be dedicated, and they have to enjoy their research. And yeah, that has to be there. It's for both, irrespective of the, I think, gender. Yeah.
Thank you, ma'am. And yes, we should have a passion and responsibility toward whatever we do. So, ma'am, there's a question from Dr. Gupta Kumar that there national regulation related to persistent contaminants? There was a ban on use of endosulfan by the High Court. So, ma'am, who wants to answer that?
See, the ban came like after a lot of papers started coming in, and if you remember, we worked with the same doctor who was also there in this Amir Khan show, like in Kasaragod, that tragedy that came up. So only when researchers come up with a problem, it's not just in India, across the globe. When researchers say there is a problem with methyl mercury, then only some other issues came up and some regulations came up. So similarly, endosulfan spraying. Endosulfan was being sprayed 4 times a year for a span of 24 years. So once it is banned, it's fine. Like, we are not allowing more molecule to come in the system, but there are 2 problems. One is what already has entered the system, because of the persistence, it is not going out of the system. We have to take care of that, which is missing. Second is endosulfan is used in different trade names, because there are many people, including the tea estate, owners, they have also come up like, can you have a better solution? They actually don't have a better solution other than using endosulfan. So endosulfan is many a times used under different trade names. So these 2 are big areas which, even though legally we are banning it, but we need some solution or a replacement for endosulfan. See, saving lives at this moment is more important than somebody impacted by cancer down the line in another 10-15 years. So that's where I think there is a gap, and many of the researchers are possibly working in this gap. We need to highlight this more.
Okay. Dr. Shantanu Majumdar has raised his hand. So can you please ask your question?
Hi, good evening, everyone. So first of all, like all the talks were really, really insightful. And talking about the gender equality in STEM, at least I can see 2 of the leading women scientists in India talking about a really, really important problem, and that keeps me as an Indian, gives me a lot of pride, to be honest, because I've seen people all around the globe, and to see 2 of the leading Indian women leading the science, particularly in this field, is really, really encouraging. So congratulations and thank you for that. So my questions are related to both science and the policy. So I would talk about the science first, and either of you can take the questions and answer it. It's not a problem. So the first thing, when we talk about the grasshopper effect, and when these organic, the persistence organics can actually move from here and there in the atmosphere. So how volatile are they are, and if some of them are photochemically active, how threatening are these chemicals to cause any SOx or NOxes coming out of it, after they breaks down, how threatening they are in terms of producing SOx or NOx in the atmosphere. Because some of them are sulfur-carrying pollutants, like, as you said, like endosulfan or the polyfluorinated sulfonates. So, my question, the first question is that, and the second one is, when all these organic pollutants, they mobilize towards the surface water or the groundwater, we all know that the groundwater or any natural water system, they too have their own organic system, the natural organic matter, be it humic acids or fulvic acids. And it's very important for them to keep the redox system or the redox ecosystem of the water intact, because we all know how sensitive the water ecosystem is towards any change in the redox system. So how interacting are these induced organic towards the existing natural organic matter in the sediment water ecosystem? So that's the science question. That's like two segments of the science question that I have.
Maybe I would like to answer the first one first. What you meant, most of these contaminants, excluding PFOS, these are semi-volatile POPs. POPs are semi-volatile compounds. So the volatility ranges between compounds. But then you were asking about the photochemical reactions in the atmosphere. Usually, SOx-NOx story, the origin comes in a different way compared to this organic contaminants. But definitely, hydroxyl radicals plays an important role in certain segments where some atmospheric chemistry reactions have been observed. And I would tell you, like, when it is going to the lower latitude regions, or like when it is and coming to this, colder regions, when it's getting deposited, there are also a lot of snow-related, reactions people have observed in the meltwaters when it's coming to the meltwaters. So not maybe directly we don't see much in the impact of SOx-NOx as such, but there can be photochemical reactions, and that also depends which region, which part of the globe we are observing this. Now, I will tell you one very interesting example. Say, even if we talked about DDT. So DDT, once it is released in the atmosphere, like once we are using it, nearly 60%, 60 to 70% DDT or hexachlorocyclohexane, it's nearly 90%, that will dissipate in the atmosphere. And what in the long term, like when it is again coming, atmospheric deposition is causing this contaminant to come to the soil. So para-para DDT will convert into DDE. And this DDE, what is there in the system, it can be there for longer time. So now your question comes again, the soil organic carbon. You know what we have seen, if it is for long term, because this is also organic molecule, which can easily bind to the organic phase of the soil or the sediment. So these hold on to the humic acid layer, like whatever the organic contaminant we have in the soil for longer time. So one thing what we have seen is, like if it is a fresh source, this binding will not happen. Like if you are using it for long time and it is getting deposited on the soil layers, it is there for longer time. Definitely there can happen some degraded product which could be even more toxic, but then the binding with the soil organic matter will be more if it is a longer phase release. So we say that is an older source. But if it is a relatively fresh source, it will not bind so quickly with the organic material. And that is how we are also distinguishing the source types. We once compared with some amount of PCBs across the country, PCBs in the soil. So this informal e-waste sector or open dumps, these are the fresh source areas. We could very well see a very good correlation with soil organic carbon and some of the heavier PCB containers. But this was not there in those areas which are relatively pristine and where the secondary sources are available. Means constantly emission and re-emission is occurring, so the binding is not so very effective. So this is what basically we are seeing in terms of POPs. And talking about this groundwater transport, there is also a factor like, to talk about the redox system, once it is getting in the groundwater, this is, again, we can consider this like PCB, if you say, you can compare this like oil and water thing. So there is a partitioning layer between that is formed between the molecule and the water molecule. So we need to understand whether that's what we are trying to do with the modeling, whether it is getting partitioned onto the water surface or it is getting into the water. Most of the cases, if it is a fresh source, it is on the surface layer. So there it comes the factor of the redox, the control, like, equal amount of reduction and oxidation. That part actually comes in a later phase. And then again, there is a possibility of different reaction that could happen, but it would take a longer span of time. It's not easy to break down the molecules, especially the halogenated ones.
I think
Thank you, Dr. Paromita. Yeah, Dr. Girija, please take some time to explain, but just wanted to remind, we are very close to the end of the session. We have exceeded and we have one or two more questions from other participants. So please, yeah, thank you.
I'll just say very briefly, Shantanu, the question was very interesting. We have seen in our study that from Gangotri, the samples which we collected from Gangotri had higher amount of PCBs, that is polychlorinated biphenyls, than the one which we collected from downstream. So that indicated it was basically remobilized into the water system because of the melting of the glaciers. Yeah, so that indicates, and it has been seen, it has been vetted by other studies also in the Alps, that near the glacier, the PCBs are very high because they get deposited in the lower temperature regions and then get remobilized. The second small thing which I wanted to let you know, that in Potomac River, which when we did study, we had collected sediment, and we had collected sediment core basically. We collected 1 meter, which is equivalent to 100 years. We sliced it and we did analysis, and we had a carbon dating. And very interestingly, we saw that the production and the import curve of DDT particularly was very much matching with the vertical profile of the DDT in the sediment. That means there was a phase lag of 32 years compared to what the production and the input was. So that is a very clear-cut indication how it is basically getting deposited in the sediments. Maybe we can connect later.
Yes, that would be wonderful. I can connect Shantanu with both of you over email, and it's great to have this continued discussion. And Dr. Mansi, you wanted to ask a question and also announce the next Wednesdays for Water session, please. Thank you.
Thanks, Suparna. And I think Angel also had a hand raised, and we still have, maybe you take Angel first.
Yeah, Angel left around at 6. Yeah, she sent a message. Yeah.
Okay. So I see Suresh ji is raising hand, not digitally, but just like this. So maybe you take him.
Yes, please.
He has been regular.
Yes, madam, very good evening. You have given a very wonderful presentation, both of you. That was very highly technical. And regarding this wastewater, I have one question. The methodology for treatment of wastewater is that you have to construct STP and treat there and divert the water for the other purposes. But the problem is that the construction of STP is a long time process, because you have to do a lot of investment, money, technology, these things are required for that. Till that we have STP, can't we have some sort of big size tanks, and we can put some chemical in that, so that the suspended particles get deposited in the bottom and upper water, which is not pure water, but which is considerably, you can say, pure water, and that water can be used for some purpose like plantation or cleaning of roads, or some this type of other uses. Can we not think in that direction?
Yeah.
Sorry.
No, please,
Paromita, please go ahead.
No, I just wanted to quickly say that, yeah, that is actually, before you go ahead with a lot of technical ways to develop a STP, that is very well taken. In our campus itself, I would say, like, we are recycling water. Of course, we have our own STPs as well. But initially, if it is not that contaminated water, we can also do the normal prelim treatment procedures, even sedimentation, decantation, and then take the upper water and recycle it. That's actually possible, and a lot of organizations are doing it. Yeah, Girija, over to you.
Yeah.
Phytorid technology is a very low cost technology, which is quite effective. And wastewater, in fact, treating it to secondary level is less cost intensive. If you're treating it to tertiary level, it's very, very costly. So we can't afford to go to the tertiary level, because there are buyers like industries which can buy it and treat it at their own cost. Treating to secondary level is not that difficult, and phytorid technology is quite effective. And as Paromita mentioned, preliminary treatment is very, very safe, but not safe for potable or groundwater recharge. We have to be very, very certain that this cannot be used for potable purposes or groundwater recharge, or even for agriculture. Non-edible crops should be basically prioritized, not the edible ones, because we have seen how it bio.
Actually, what I wanted to say, this water can be very well used for plantation. watering the plants in the city.
But then again, if it really have serious contaminants, and if it is a normal, gardening plant, like only flowering plant, if you say, then even if it is by accumulating, it is concentrated to one plant itself. But if we have to just ensure that it doesn't go out, and that no other exposure pathway should be there for those contaminants.
Okay, thank you, madam.
Thank you. Suparna, do you allow me to take over? Thank you so much.
Yes, please. Yes, please.
Okay.
Thank you so much to the
Yeah.
speakers and the discussant and the participants for making this wonderful. Yes, over to you, Mansi.
Thank you, Paromita and Girija, and it's really nice to know you from this session. And I have been knowing your name for a long time, but it's good that Suparna brought us together. I'm going to reach out to you also for Women in Water, which is another work which I'm doing. Apart from that, I also want to inform all of you that actually when we talk about wastewater, we are only talking about hardly 0.2 or even 0.1% of the water, and rest of it is water. And this is where anthropocentric way of looking at water is making such a huge problem in the whole water system. We are still talking anthropocentric when we talk about, can we use wastewater this way? Can we use wastewater that way? Because we are still wanting to ensure human consumption of it. So sometime when we do not have a Wednesdays for Water speakers, I am going to come and talk about minimalism and sustainability, and talk about why not talk about preventing, because all of us keep talking about curing. So Paromita and Girija were giving us solutions for cure. Nobody is giving a solution for prevent, and that solution lies in morality and ethics. So just to keep it short, I had question on how, as a country, Vijay Prashad in COP26 talked big about why India still can have a license to pollute. And I think as scientists, we have to really rise and say, no, if the West is polluting, we should not take it as a license, being a developing nation, to pollute. But I think hearing both of you, I'm sure you are in alignment with my thoughts. I do not endorse those kind of statements. When developed nations are polluting, that does not mean developing countries also have to pollute, especially when we know India and China are big contributors of pollution. And we cannot hide behind colonialism and westernization and capitalism and so on and so forth. With these words, definitely preliminary treatment is important, but we have to still talk about waste segregation. And I'm happy that both the speakers touched solid waste. And that's where we are going to take up the next session, which is a follow-up of this session, where we are going to talk about one part of the waste, which is organic waste. And both the speakers are here today. They are listening to both of you because they will take up the answering of your questions here. And yes, two wrongs don't make it right. Thank you, Fawzia. I love you for that. And we have to take moral responsibility as a country. So our speakers for the next sessions are also here. And I'm really thankful to both the speakers who are talking today and our dear student Aradhna for being a wonderful discussant, and the future speakers of the next sessions who are all ready to give us ways. How can we reduce? How can we prevent the waste which we are talking about? And they're going to talk about role of bioenzyme in water purification. If we can reduce the quantum of waste, at least we are talking a bit of prevention. So that's our session on 19th. We really look forward to having you. And I again thank all the participants. We have some patrons who have joined us for months now. We want to thank them particularly, because they encourage us to keep on doing this session. We are nearly completing 9 months of Wednesdays for Water, all set until March, just to let you know. So please come back again on 19th, same time, 5 p.m. Role of bioenzyme in water purification. And we have a gender balance session. So men will not have problems on that. Thank you, everybody. Please take care of yourself. We love you all. Bye-bye.
Thank you.
Thank you, presenters, for joining us today and enlightening us with your wisdom. Also, thank you all the participants for joining us and making the session interactive. Besides walking and talking water, worries and wisdoms collectively, we see this as a platform to cross-connect and expand our network and explore possible collaborations. We are also making notes to publish both scientific and non-scientific work. Here is a glimpse of some of our writings. You may reach us through email, LinkedIn, Facebook, Twitter, Instagram, and also look at our website www.w4w.in. We look forward to your suggestions and comments to make the series more meaningful and engaging. And meanwhile, we hope that you appreciate today's session. We represent Tata Institute of Social Sciences, Hyderabad, Terry School of Advanced Studies, New Delhi, Environmental Design Consultants, Ahmedabad, FluxGen Sustainable Technologies, Bangalore, Counterview, and we are supported by Wiki's Water Resources Council. We truly appreciate your support and encouragement in conducting this series, and we hope that you will stay tuned with us through our social media platforms and our website, and you will write to us at our email IDs.